The question we are solving here is for 2018 midterm 1 question 2. Very similar questions. It has been examined many times. So we have one signal x of t which has two pieces, another signal yt which also has two pieces. The question is to find this integration. How do we solve that? So we start from two vertical axes. Again, the axis represent what we are integrating. We are integrating over s, so therefore I write small s on top of the vertices to the axes to remind me I'm integrating over s. The first vertical axis represents x of s, and I know that x of s will be everything once it's larger than 2. If s is larger than 2, this part is E2js. And this part will be 0 completely. All I did was copying x of t into this vertical axis. Everybody is okay so far? Let's now look at the second axis. Second axis is representing y.5 t minus s. To do that, I need to write it down what is 0.5 t minus s in terms of s, because now I'm integrating over s, I want to rewrite it into this.
So 0.5 t minus s is less than or equal to 2.
Pi 0.5 t minus s. So every time I see t, I replace it by 0.5 t minus s. If 0.5 t minus s less than 2. 0 otherwise. But now I want to rearrange that so that it becomes a range over S. So if I rearrange them, I got what? I got 4. So if I rearrange them, I got t minus 4 no less than s. No larger than, no less than s. Just rearrange the equation, gives me s larger than or equal to t minus s. Once I have that, now I know what do I need. I want t minus 4. And whenever s is larger than t minus 4, so this part gives you what?
0.
Pi 0.5 t minus s. And this part gives me 0. That's by following this equation.
But it has to be t minus 4 is less than s. So
that's right. It means s is larger. Whenever s is larger than t minus 4, I got something that is non-zero.
Okay.
When s is less than t minus 4, I got something less than 0. It's very important. You are now comparing s to another number. So s is the vertical axis we are looking at, s versus another number.
Okay.
So far, so good.
Yep.
This is actually the hardest part. Once you get that, I believe the rest is much easier. The first case will be the range for different t is going to move up and down. The first is when t minus 4 is
Greater than or equal to 2.
I always start from less, so
Okay.
t minus 4 less than equal to 2. You can do greater as well, but I always start from small. So I know that I start from bottom, move up to the top. Different people have different choices, preference, but that's what I prefer. So once you know that, you can see it means t is no larger than 6, so that's the case for case 1, condition for case 1. That is when t no larger than 6. That's what you get. Now we can finish the calculation. We are taking the product of everything. So therefore my v of t will be what? Integration from where to where?
2 to infinity.
Very good. So you got the right idea. 2 to infinity. Everybody is okay. And the integrand is
2j t
t 2js, not t, very important, 2js
Yeah.
times e
pi 0.
pi 0.5 t minus s ds. Obviously, you treat t as a constant, move it to the front, you can solve this integration. Would it be okay if I stop here for the calculation?
Yeah.
You should be able to go
I
back
can
and
do that in
finish.
your
Case 2. Case 2 is when t minus 4 is now getting larger. How large it is? It is now larger than 2. That's the second case. For this case, t minus 4 larger than 2, or equivalently, t larger than 6. And you can probably continue it by yourself. Your z of t will be from where to where?
t minus 4 to infinity.
Very good. It's going to be from t minus 4 to infinity. And the integrand is
Same as the other one.
same as the other one. But the range is now different. Again, I'm trusting everybody knows how to finish this integral. So therefore, we can stop here. Yes. Have I answered your question?
Yep.
Everybody's okay?